Okay, in part 2 of lesson 2.3, we're still dividing polynomials using long division. All they're saying in this example is that you don't always have to get a remainder of 0. Sometimes you get a non-zero remainder. So we're going to plug this back into just a couple of really simple examples. For instance, if I take 65 and I divide it by, actually I want to use 65 divided by 5. Just like we did in the last one, we say, well, how many times does 5 go into 6? It goes in once. So we take 1 times 5 is 5, then we subtract. Now, with numbers, we really don't draw the line, change the signs, but if I drew the line, change the signs, then I can add. So that would be 1. Then we bring down the next number, which is 5. 5 goes into 15 3 times, and 3 times 5 is 15. So we draw the line, change the signs, add, we get 0. And we'd have a remainder of 0. Now that's what we saw in the first example. When we took a polynomial by another polynomial, we ended up getting a remainder of 0. But this doesn't always have to be the case. This is where I was starting off. If we took 65 divided by 4, same procedure. We ask ourselves, how many times does 4 go into 6? Or what do I multiply 6 by? Is 1. Or 4 by? 4 times 1 is 4. Draw the line, change the sign. We're going to add them, so that is 2. Bring down our next number. That's 5. So now how many times does 4 go into 25? That is 6 times. 6 times 4 is 24. Draw the line, change the signs. We subtract, get a 1. Now we got a remainder of 1. There's lots of ways that we've learned how to write the remainder. There's one way where we just put R1. Other ways are to go 16 with a remainder of 1 over 4. So it's 16 and 1/4. So you got 16 and 1/4, the same thing as 16 with the remainder of 1. Other times you've seen where we've added some decimal places, and then we just keep dividing till we get a remainder of 0, so 16 1/4. But the main focus they're going to work on here is, if you write it out of this remainder, then to double check your answer, they're saying what you can always do is you can always take your divisor, that's the one that you're dividing by, you can multiply it by your quotient, that's the answer that you got, 16, and then you can add your remainder, and it'll give you the dividend, which is what the number you started dividing into. So if we do this, we can check it by taking 4 times 16, and then we would add the remainder, and we should get what we started with, 65. And 4 times 16 is 64, plus 1 equals 65. You bet, that's our check. Now in essence, that's the same thing they're describing to you in this part up here. If you read through that textbook, they're just reinforcing that concept, that you can always take the number you're dividing by times the answer that you got, this is the divisor, times the quotient, and then add your remainder. You should always get what you started with, which is called the dividend. So really there's no difference in the procedure that we're doing here. We're still going to be doing long division. We're still going to use the same process. They just want to point out that they don't always have to come out even. And my purpose of showing you this graph is, if I take this polynomial divided by 2x minus 3, well, if 2x minus 3, if that's a factor, and we say it's equal to 0, then 2x equals 3, or x would have to equal 3/2, which means would our graph cross at 1/2, and that looks like it's a pretty good fit. So we don't always have to get a remainder of 0. Sometimes we will, sometimes we won't. So we're going to extend the page, and we're going to try our long division. 8x cubed minus 18x squared plus 21x minus 20. We want to divide that by 2x minus 3. So this is the meat and potatoes right here. This is what they're wanting us to try to do. Learn how to do long division. So what do you multiply 2x by to get an 8x cubed? Well, 2 times 4 is 8, so I know I need a 4. And x times an x squared is x cubed, so I know I need an x squared. So that's going to be 8x cubed. Now I got to multiply it by -3. So 4 times -3 is a -12. X squared. Now we're going to draw the line and change the signs and add. So our x cubes are going to be eliminated. We're going to have a -6x squared. After you get done with that, you bring down your next term, so plus 21x. Okay, so now we come back to our strategy of, what do I multiply 2x by to get a -6x squared? Well, I have to take 2 times a -3 to get a 6, and I got to take an x times an x to get an x squared. So I'm going to multiply the -3x times everything. So this -3x is going to be multiplied by 2x, which is a -6x squared. The negative 3x is going to get multiplied by the negative 3, so that's going to make it a plus 9x. Okay, now we're going to draw the line, change the sign, so we're going to change that to a plus and this to a minus, and we're going to add. These terms will reduce. We got 21 minus 9, so that gives us 12x. Next thing we do is we drop down our next term, which is a negative 20. So what do you multiply 2x by to get a 12x? Well, the x's are already there. All we need to do is multiply by 6. So we're going to put plus 6. So 6 times 2x is 12x. 6 times negative 3 is negative 18. So then we draw our line, change the sign, so minus and plus. And what we end up with this time is a remainder of 2. So now what we do is we express our remainder as R2. That would be one possible way. Another possibility, and this is the way that they want us to write it, would be take your remainder and write it over your divisor. So it's plus, because we've got to add on our remainder of 2 over 2x minus 3. Now it didn't go in there evenly, so that means that graphically, that we saw at the beginning, since it didn't go in evenly, that this 2x minus 3 cannot be a factor, so this graph is not crossing at exactly 1.5, so it's off of that, or just a little bit, but that's the process of long division. Okay, the next one, we're going to take this polynomial and divide it by x minus 5. It's very apparent it doesn't even cross anywhere near the positive 5 over here that it would have to be in your graph, so it probably isn't going in there evenly. Put a negative 3x cubed plus x squared plus 4x minus 66. We want to divide it by x minus 5. So what do you multiply x by to get a negative 3x cubed? Negative 3x squared. And negative 3x squared times x is a negative 3x cubed. Negative 3x squared times a negative 5 is a positive 15x squared. Draw the line, change the signs, and then you add. These will reduce. Next thing we have is a negative 15x squared plus an x squared. That's a negative 14x squared. After you get done with your addition, bring down your next term, so plus 4x. And now we go to our next part. What do you multiply x by to get negative 14x squared? And that would be a negative 14x. So now we take a negative 14x times x, which is a negative 14x squared. We take a negative 14x times 5, it's going to be positive, and that's 2070x. Okay, so then the next thing that we do is we draw the line, change the signs. I just got to move down a bit. Draw the line, change the signs. These are going to reduce. What we end up here is a negative 66x. Bring down your next term, negative 66. What do you multiply x by to get a negative 66x? And that is a negative 66. So negative 66 times x is a negative 66x. And negative 66 times a negative 5 is going to be a positive. And 66 times 5 is 330. Draw the line. We're going to change the signs. And now we're going to add. These will cancel out, and we've got a negative 330 minus 66 would be a negative 396. This is our remainder, so we can either put plus or negative, and I guess that's probably the way I'm going to go. I'm going to go plus, and then we have a negative 396 over our divisor, which was x plus 5. Okay, so the only thing different here is that we don't always have to get a remainder of 0, so our long division can show us that, which basically means the x minus 5 is not a factor of our original polynomial. So, long division with remainders.